All right, honors chemistry. Here's another percent yield example. So let's do number 6. It says in the reaction between excess K, it's nice that it's already telling me that it's an excess. And the reaction between excess K and 4, oh, sorry, my thing is getting blurry, and 4.28 grams of O2, so they react. So in the reaction between these two, that means those are reactants. And the reaction between excess K and 4.28 grams of O2, potassium oxide is formed. How about from this first sentence, I can begin to write the balanced chemical equation. So it says in the reaction between excess K and 4.28 grams of O2. So how about just K and O2? Potassium oxide is formed. Now, I noticed this on a quiz before, but a lot of us were writing our formulas wrong. Again, we have to take a breath and go potassium oxide. Potassium is K plus, and oxide is O2 minus. Where do I get those charges? From the periodic table. The group or the column that they're in will tell me the charges. And then I could do crisscross method. I could do common multiple method. I'll just do crisscross method. K plus 1, 1's going to go down by the oxygen. 2 is going to go down by the potassium. So K2O. Okay? Now, if I want to begin to balance this, I could draw a bunch of particle diagrams. But I see that there's 1 oxygen and 2 oxygens here. So I'm going to put a big 2 in front of here. And so now I'll have 2 oxygens here and 2 oxygens here. And then I also noticed that that made me have 4 Ks. So I could just put a big 4 here. Then the equation is balanced. Okay. Reading the question again, it says, in the reaction between excess K, so I could do B, C, A. It says it's in excess, so I'll do excess, and 4.28 grams of O2. I'm going to have to convert that to moles later. What mass would you expect to form? That's going to come from the BCA table. So this is the expect to form. If 17.36 grams of K2O is actually produced, what is the percent yield? All right, so if it says what do you expect to form, I need to look at this BCA table or do my mole ratios. So first, like on the side, let me convert my 4.28 grams to moles. Be careful, the molar mass of O2 is not 16, it's 32 because there's 2 of them. So I'll do 4.28 grams of O2 divided by 32 grams per mole because, again, grams divided by molar mass is moles. So 4.28 divided by 32, and I get 0.134 moles of O2. I'm going to put that here. 0.134 moles. And since it gave me that mass, all of it's going to be used up. So minus 0.134 moles. Looking at the balanced chemical equation, or I could just show you the dimensional analysis. For every 1 mole of O2, I get 2 moles of K2O, right? It's from the balanced chemical equation. So if I do my stoichiometry, 0.134 moles of O2 times, if I want K2O, I have to get moles. 2 moles of K2O for every 1 mole of O2. Basically, I'm multiplying it by 2. So 0.134 times 2 divided by 1. 0.134 times 2. I get plus 0.268 moles of K2O. This is going to be my theoretical yield in moles. Okay? And then if I wanted to figure out how much potassium I use, it's not part of the question, but I'm still going to use that ratio. It's a 1 to 4 ratio. So I should have 4 times the amount of K. Some of you have been doing divide by 1 and then multiplying by 4. I could do the same thing if I do 0.134 moles of O2 times there are 4 moles of K for every 1 mole of O2. Right, so this is dimensional analysis. You always have to go from moles of one to moles of other using this mole ratio that you get from the balanced chemical equation. So if I multiply that by 4, that's how many moles of K I'm going to get. So I'm going to use 0.536 moles. Now, we don't need this for the question, but I wanted to show that as another example. So now I expect to get 0.268 moles of K2O. To convert that to grams, I need the molar mass of K2O. And so K has a molar mass of about 40, I believe it is. So K, no, 39.09. So there's two Ks. So 39.09. So there's two Ks. So I'm going to do the math. 39.09 times 2. There are the two Ks, and there's 1 O, so 16. The molar mass is 94.18. So the way that I get the molar mass of K2O is by adding up all the masses. There are two Ks and 1 O, so about 94.8. So if I multiply by the molar mass, which I'll multiply by 94.18 grams per mole, I'll get my theoretical yield. So 0.268 times 94.18, and I get 25.2 grams of K2O should form. That's directly from the mole to mole ratio of oxygen to K2O. This is my theoretical. And then it says, if 17.36 grams actually produce, what is the percent yield? So if this is my actual yield, and like they give you keywords in the problem, so it says that 17.36 is my actual. As mentioned above, percent yield, this is percent yield, is actual over theoretical times 100. So my actual is 7.36 grams, which was given in the problem, over my theoretical, which is 25.2 grams, times 100. 17.36 divided by 25.2 times 100, and I get about, I'm going to say about 69%. So that is my percent yield. Okay, so here's another kind of quick example of writing and balancing a chemical equation and then walking through doing percent yield. If you want, I'll make another video and I will have it there for you to do number 7.